to continue from where we left off. Okay, so we have the vectors. We had a force going this way. Okay, F was what? Was 400 Newton. We had our acceleration. We've calculated acceleration to what? 0.5 meters per second square. And what again? We know the mass. The mass was 25 kg. 25 kg. Okay, and we are to find what? We are to find the coefficient of kinetic friction. We have G has also been given us 9.8. 9.8. Okay, the force is 400, so we have 400 here. Then the angle here is what? I think 50 degrees. So we got 50 here. Okay, but like I was saying, once we resolve this force, okay, the alternative route will be down and what? To the left, okay? So this will be a negative vector. That will be negative what? 400 is the opposite side. So that's 400 sine of what? Sine 50, okay? Sine 50 here. This will be 400, but this will also be negative, okay? 400 cos 50, which will also be negative. Okay, so we take note of that. Then because we are pushing on this object, which means that acceleration is going that way, okay, which is also negative, right? Then the frictional force on the system will also act this way. It always opposes what? Motion, okay? So mu r will always oppose what? Relative motion. We take note of that. Okay, mu r will always oppose relative motion. But another thing we have to take note, let me clean this one for now. So another thing we have to take note of is the weight. We got a weight, okay, down, which is 25 times what? Times 9.8. 9.8. Then we also have the normal reaction R, okay, up here. So now we are set to write our equations. So let's take from X. Let me split the screen. So X component, I have R, which is positive, minus what? 400 sine 50 minus the weights. So I'm adding all the vertical forces, okay? Minus the 8, which is 25 times 9.8. Okay, and because the body is only accelerating in the horizontal direction, but not in the vertical direction, the acceleration in the, oh, sorry, this is, I'm looking at Y first, okay? I think I wrote S, I wrote X initially. So we are in Y components, okay? So take note of that. Yeah, so like I'm saying, in vertical direction, there is no motion. So acceleration in the vertical is 0. Okay, so this will give us net force. There is no acceleration, so that will be m times 0, which will essentially be what? Which will be 0. Okay, so that is your first equation. You should be doing the multiplication for me. For example, sine 50. So let's rewrite that r minus what? 400 times sine 50 will give us Answers, please.
So it will be 306.
We have a 306.
06.41.
0.41.
0.41.
Okay. Then
Yeah.
25 times 9.6. 25 times 9.6.
45.
45. Okay. So let me simplify further.
245.
Add this 245. Okay, so R will be add this 2 for me. That'll be what? 5 what? 551 point what? 41, if I'm right. Are we correct?
Yes, sir.
Okay. So now let's take the X component U. So in X component, we have frictional force, like this is mu R, okay? So I'm going to write it straightforward, but because it's to the right hand, that is positive, okay? So this will be mu R, okay? Mu R positive minus, this is negative, okay? So minus 400 cos 50. So write that, you have to calculate that for me. 400 cos 50. 400 cos 50. Okay. And then this time the body is accelerating. The acceleration is to the left. Okay, so we have negative A is negative MA, right? Negative MA. Okay, you let me write negative MA first. Then when we are done, we write everything. So that will be mu times R is what? 551.41. Then 400 cos 50. I think somebody has given me that is okay, 257.12. So 257.12. And then this other side will be M is 25. Okay, so let's do that calculation here. That is 25. M is 25. A is 0.5. So when you multiply that, that should give us what? 12 point what? 12.5 negative. Okay, 12.5 negative. Okay, so let me put the minus here. So negative. Okay. So once that has been done, let me clear this other side. Okay. So once that has been, we have okay. So we're going to simplify, which means that mu will be equal to what? Mu is equal to what? Minus 12.5, okay, plus 257.12. Okay, then I'm going to divide through by 5, 5, 1.41. So add the numerator for me. That will give us what? When we add that, I guess that should give us 2 what? 2 4 no 2 yeah 2 4 what? 2 4 4 244 point what? 6
244.6.
62.
269 point
Okay. So over 5.
269.62.
Are you sure? Please check it again.
Yes, sir.
No, this is negative 12.5 plus 257.12. So Joe, check your calculation again. So this is over, yeah. So over 551.62. So when you find, give me the final answer. So when you divide, what do we get? When we divide, what do we get when we divide?
0.
Yeah, so 0.444434. Okay, good. Thank you. Yeah, so that is the coefficient. That is the coefficient of friction with
0.44, sir.
yeah, so 0. Okay, is the final answer. So that is how we get the coefficient of friction for this dynamic system, which is very exciting, okay, to find. I'm sure you are very excited about that, but our time is running very quickly. We have less than 10 minutes on the dot to go. Okay, now let's see. There is another one here for you. This time you are going to solve it because I've resolved this system earlier for you. The only inclusion you are going to add will be the friction. Okay, so you're going to try it at home also for me. Okay, give it a try at home. Okay, we don't have much time to look at it in class. Then anyway, I've already resolved it. So when you try it, compare with the solution I have here. Okay, it's straightforward. The only difference will be the frictional force. I've solved it on the slide. Yeah. Then what again do we have here? I think it's another question. We have to obtain the magnitude and direction. And there is a quiz. So basically that brings us to the end of this slide because there is a quiz after it. But as we are aware, we can't take quizzes in class, okay? But if we are being in class, we would have taken this quiz. Then find the mass, given the mass and given the mass, you'll be asked to find the acceleration and the tension, okay? So in that case, when you're asked to find acceleration and tension, all you need, you have the formula for acceleration, you have formula for the tension. So you just have to substitute, okay, the given formulas. You just have to substitute the given values into the formulas to get your acceleration and your tension. So for example, in this case, acceleration will be what? M2 is 15. Take into notes, okay, that in our earlier formula, we said M2 is bigger than M1. So in this case, that gives us this formula here. So in this case, indeed, M2 is bigger than M1. So we apply the formula as it is. So that will be 15 over what? 15 plus what? Plus 6 Okay, all times what? Times 9.8. Okay, the same way with the tension to find it. Start.
Yes, sir.
Okay, so I think that would do for this class. Some of you keep unmuting your mic, but you're not saying anything. Okay, let's continue. Aristide, please, if you unmute your mic again, I'll take you off. So take note of that. We are getting too much feedback from you. Okay. Yeah, any questions so far? Any question? I think we are there. Any questions so far? The next point you'll be looking at is the work energy theory, where we'll look at Mike has his hand up. Yeah, so Mike.
So sorry, I wanted to ask about the assignment you gave online.
Okay, what about it?
I don't know. Some of us are yet to see our grade, so I don't know. Do we have? I submitted my own a day before the deadline, but I'm yet to see
See your grade
the
for
grade.
which one? For which
I don't know what the problem is.
See your grade for which one?
The assignment one first.
Okay.
The first assignment.
Sir, same to me.